Greetings and salutations. Today I'm going to show you how to set up a photoresistor so that way we can measure the incoming light. And from that measurement, from the incoming light, we're going to take two servos and we're going to rotate those servos by different equations. So one is going to be a linear equation and the other is going to be a square root equation. This photoresistor is called an LDR, which is a light dependent resistor. This light dependent resistor is connected to another resistor, which is 10 kilo ohms. So be sure to include that when you're placing your resistor onto the breadboard. So we're almost done with the photoresistor. Now let's go ahead and include the two servos. So whenever you're connecting your two servos, you'll notice that there's three wires connected to it. So one is red, which is the middle, one is brown, and the other is the signal wire. So that one is going to be color-coded orange, and that's the wire that's going to control your servos. It's going to be controlled based on the light coming in from your photoresistor. So anytime we're connecting to ground, notice that we're color-coding it black. Anytime we're connecting to the positive terminal, we're color-coding that red. So that red is the power, which is going to 5 volts, and the black is going to the ground. For the two servos, we connected them to digital pin 10 and digital pin 9. So those are the two pins that are going to control our servos. Okay, now that I have my circuit set up, what I want to do is I want to move these servos based on a few equations. So let's say the servo here, we're going to move that based on some square root function. The servo here, we're going to move that based on some linear function. And the dependent value, or the dependent variable, is going to be the light coming in from your photoresistor here. So we're going to measure the resistance given by the light. So to do that, let's first identify some inputs and outputs. So here are inputs, and here's the section for our outputs. On our input, we're going to read the values coming in from this photoresistor. And if you look at where your photoresistor is connected to, it's connected to analog pin 0. So if I read analog pin 0, I can provide some output. So let me go ahead and output that information. And so to output any kind of data, you would want to print the input. So we're going to print the input values here. And if I start my simulation and hit the serial monitor, I can manipulate the brightness and I can see my max and min. So I got a max value of 679, I got a mix value or a min value of 6. So based on those values, I can now manipulate my servo because now I have my domain provided for me. So I'm going to go ahead and create two variables. So I'm going to create an independent variable called x. Actually, this is our dependent variable. I'm going to go ahead and create another variable. We're going to call this y1. And a third variable, we'll call it y2. So now I'm going to set my variables to my analog pin here. So I'm going to go ahead and select X. I'm going to select X, and that is going to read my analog pin 0 or A0. So now every time I run my simulation and I want to look at the values, those values are now stored as the variable X. Okay, so now that we have our values, create a function. We'll call this function y1, and within y1 we're going to take our x variable and we're going to multiply it by 0.5. So in here I'll just type in 0.5. So this is 0.5 times x. So this is going to give us our linear equation. So now we can create our square root equation. So to do that, we're going to go to variables, and I'm going to set another variable here, call this y2, and within y2 is going to equal the square root of x. However, I also would like to multiply this square root of x by some value. We'll say in this case, we'll say 6. So now we have two functions. We have a square root function and we have a linear function. And what I want to do is I want to see how those two functions manipulate my servo, or use those two functions to manipulate my servo. But let's first print out what's going on here. So to print an output, we simply print serial monitor, and we're going to print the variables. I want to print x first, and we can do the same thing for y. So what I'm going to do is I'm going to provide a space here, because when you're printing information you don't want those integers to appear in one line. So I'm going to say without the new line there's going to be a space, and now I'm going to go ahead and print my first function. So all three of these would be in one line, and the next new line would start right after y1 was read. So let's see how that's going to look. So if I click on serial monitor, I'm going to click here, and I see a bunch of integers connected to each other, so I guess I didn't put enough spaces here. So I'm going to put a few spaces here, see how that changes my code or my output. And as suspected, there's now a space between my y1 value and my x value. So if I move or toggle the slider, you can see how my corresponding y's and x values change. So then we can apply the same method to print the next function. So I'm going to go ahead here and just simply take out and put in x1 or put in y2. Actually, we'll leave a space. So make sure that only the last integer you want to print is a with selection. So let's go ahead and start the simulation and see if we can identify our three variables here. So we have x, we have y1, and we have y2. So if I change my x values, you could see the corresponding y values change as well. Now that I have my x values, y1 values, and y2 values, I'm going to go ahead and use my y1 and y2 values to manipulate my servos. Now I want my servos to move from 0 to 180 degrees, so I need to minimize the values coming out of my y1. And to do that, I need to kind of tailor or map my x values. So I'm going to go to math, and I'm essentially manipulating the domain at this point. So if I start simulation, my domain starts at 6 and ends at 679. So I'm going to go to map here, and I'm going to constrain those values, or I'm going to map my analog 0 values from, let's say, 0 to, we'll do 255. And if I start simulation and I toggle the slider, I'm going from 0 to, in this case, 169. So those are my new x values now. I have a new domain. I'm going to go ahead and use those values to manipulate my servos. So to move your servos, it's an output So you can go to rotate servo, and you can rotate, in this case my servo 1 would be on pin 9, servo 2, actually I need to go ahead and connect these. They weren't connected to my power source. Okay, so I'm going to change this to pin 9, and it's going to move based on values of Y1. And I'll do the same thing for the other servo. In this case, it's connected to pin 10, and I want it to move based on values for Y2. Sorry, I forgot to make this a multiplication. It was a plus. And now if I run my code again and manipulate my toggle slider here, you'll see that at a certain value I get the same degrees. So you can just move this until it reaches a certain value. It looks like at 143 they get pretty close. And if you click on the plotter, you can see how it changes based on time. But we don't need that information right now. So it looks like at 143 they have the same value here. They're both at 71 degrees.